Hi, my name is Jessie. I'm with Wolfram Research, and what I'll be showing you today is sort of the ease of use of the Wolfram neural net framework. And on the left-hand side, I have a Wolfram notebook with the Wolfram language, and then on the right-hand side, I have a Jupyter notebook with Python, and I'll be using the analogous high-level Python framework called Keras to be doing the exact same workflow. What I'll be doing specifically, as you can probably tell from the title, is I'm going to be using a convolutional neural network to determine whether or not an image is a hot dog. On the left-hand side, I've already got the images loaded, and I've already done the pre-processing involved, which in Wolfram language is not very much. I've just resized them, the images, and combine them, so we can take a look at that. So it's just the images that aren't hot dogs combined with the images that are hot dogs. Pre-processing was a little bit more involved with Python because you have to, the read and prep function requires you to sort of, first of all, you have to import the file path, and then you load the image, and then you sort of turn it into a NumPy array, and that is what is fed into the neural network. But now that we have, our data set pre-processed, let's go ahead and sort of get started into the bulk of the workflow. And for this one, we'll be using pre-trained neural net models to start with. And that's kind of the direction of deep learning now, is to use these pre-trained neural nets to get up and going with the problem at hand. And in the Wolfram language, we have the nice ability to grab one of hundreds of pre-trained models from the neural net repository. And you can do that within the language itself. So let's do net model. And you can see just from this drop-down menu that you can choose from literally hundreds. And you can select it without having to really know necessarily which one. But we're going to go ahead and choose ResNet 50, just trained on ImageNet competition data. So it pulled this from the neural net repository. And I'll get back into this in a second. I did the same thing here in Keras. There are about 3 or 4 pre-trained neural net models in the Keras library. But I mean, there's only 3 or 4. So it really sort of limits the ability to the kinds of problems you can work on very quickly. And so here, ResNet 50 specified the weights, which basically just means, what the model was trained on. And what I like about the Wolfram language neural network framework is that each, layer is a clickable object with that is symbolically represented in the language itself. And each of these layers has a key, and the actual layer itself is the value associated with it. And there are many surgery functions in Wolfram language that will allow you to sort of take a layer, extract a layer to sort of analyze it further. And that's only possible because of the way that neural networks are symbolically represented in the language, which I think is pretty cool. Anyway, that was just sort of an aside. Now that we have our pre-trained model, we just kind of want to get a feel for how it works. So let's go ahead and do some initial testing of the model on a given input. So input random sample, and let's do 20. So this will be our input, and it has sort of a nice mix of hot dogs and not hot dogs. So instead of reevaluating it, I will just delete the output. So let's do model, input, and then I kind of want to see, so what this neural net is going to do, it's going to try to analyze every single image and determine what exactly the image is. So since it can be a bunch of things, I kind of just want the top 3 most likely things that it will, the machine will attempt to identify it as. Interesting. So, and let's sort of take a look again at what the input was. You can see for all of the hot dogs, it's got, a 99% chance that it's a hot dog, but it has also some other things it thinks it could be. The non-hot dog images are a little bit more opaque. It's a little bit less sure what they're going to be. And I did largely the same thing here in Python as well. Again, I did some type checks just to make sure I'm working with NumPy arrays. And you can see here that it's sort of generally just the same thing. Anyway, now the main point of this is the ease of altering a given pre-trained model to do transfer learning. And what that is it's the ability to take a network that's already trained and use it to tackle a similar but perhaps slightly different problem. And one thing that we can do is what we want to do. Remember, what we want to do is identify whether or not an image is a hot dog or it's not a hot dog. We don't really care about what the not hot dog image actually is. We just want to know it's not a hot dog. So what I'm going to do is I'm going to take the pre-trained model that we had before, and I'm going to drop the last 2 layers, and this is pretty easily specified. Whoops, I spelled that wrong. And so it outputs a NetChain model, and you can immediately see that both the linear and the softmax layers have been dropped. I largely did the same thing in TensorFlow, with Keras TensorFlow backend that I'll detail in a second. Now what I want to do, now that I've dropped the last 2 layers, is I want to create a new model. And I want this new model to have a different linear layer and a different softmax layer because the classifiers are going to be different. So we need to account for that. So the first NetChain is basically just linearly stitching layers of a neural network together. So the first layer to be stitched is this whole dropped network. So basically this large thing, which actually consists of, I think 23 nodes or 24 nodes. And then let's add a linear layer. And then softmax layer. And I really, whenever I can't spell anything, I really do like that. I have autocomplete fill with Wolfram language. I mean, with just the Wolfram notebook in general, you don't get that with Jupyter, which is a little bit irritating. So here I'm specifying my class as hot dog, not hot dog. Okay, so immediately, like when it outputs this NetChain object, it's telling me that it's uninitialized, which is good. Sort of reminds me as a user that, hey, you need to actually train this to be able to use it properly. Now, again, I largely did the same thing here in Python. I specified the number of classes 2, but there wasn't really an easy way for me to specify like what I want to call those 2 classes. You see them, they're documented here, but they're not going to be represented in the final output. Sequential is akin to NetChain. You can also see here, I haven't trained this new model yet, but transfer learning with the previous pre-trained model in Keras, you specify, basically you only want to train the top 2 layers and the rest of it you don't want trained at all. So I have it set to false, which you can do the same thing once you train when you're training a neural net in Wolfram language, you can do that same thing with something called learning rate multipliers. It's a little bit more robust, which again I'll show you in a moment. But for now, I need to reformat the training data before I can do much. So I want to new hot dogs, random sample. Oops. Let's do 10. And then hot dog input. And basically just telling it here, hey, these are hot dogs, so that it matches the classifier that I've identified, that I've created in my new neural network. And then for the non-hot dog images, sort of the same thing here, basically just telling it, hey, these are not hot dogs. Okay, and then finally, training data, just take the union. Union's a nice function because it gets rid immediately of any duplicates. Which is, you don't want to have duplicate training pieces of training data. So here you can see that immediately the hot dog images and the not hot dog images are threaded accordingly. We'll go ahead and get rid of that. Okay, now on to training this new model. It's largely the same deal as using the pre-trained model. However, you just need to initialize it using nettrain. Once you have your new model going, specify the training data. With learning rate multipliers, I can specify exactly which layers I want to train and which ones I don't, using pattern matching arguments, which is kind of the bread and butter of Wolfram language, which makes it a very robust option. That isn't the case with Keras. You just kind of, it's a true or false sort of thing. You figure out, okay, what layers are trainable and which ones aren't. And here 0 is basically saying, well, the first layer of the new model that you've created is the pre-trained model, so don't want to train it. So it's a little bit limiting in that regard. So I'm going to go ahead and train this new model. You can see that Atom Optimizer has been selected as the method. I didn't have to choose that, though I could override that if I wanted to and select a different optimizer. That isn't the case here. You can see that when the new model is being compiled, you have to sort of specify that manually. You have to also specify these other metrics and properties. Okay, so I have my new model, and I want to go ahead and sort of check out how well it did. And again, I largely did this same thing in Keras with the TensorFlow backend. So again, sort of created the model here, and I'm going to go ahead and test how well this new model worked on our interesting problem of identifying hot dogs and not hot dogs. So input. So let's go ahead and test this puppy out. And this will take a minute. Oh, that was not as long as I expected at all. So it looks like it did a pretty good job. Nice. Okay. Wow. And here you can see I've done the same thing. I've created my predictions, and again, one of the nice things is that you don't really immediately know which which value is which. I can kind of guess based on how accurate the model is. Like this first entry is probably probability that it is a hot dog, and the second one is likely probability that it is not a hot dog. And I can guarantee that by finding an image that is not a hot dog. Not that one. Yeah, so there's about 94% that this is not a hot dog. So don't really have that problem here because you specify the classifiers as strings, and then it sort of remembers that when you thread, the results together. And again, the images are automatically displayed because the images are actual input objects into the neural net. There's no going back and forth between arrays and images, which is really, really nice. Lastly, I just want to touch on one thing that you might have noticed on the right-hand side is that I was using a nice function that I used in Python called image data generator, which allowed me to batch upload, all of the data into its, right sets. And this is really good. It's a little bit more complicated, but it's great for out-of-memory data. You can do this in the Wolfram language too. It's just the training set was, fairly small, and the workflow is quite simple. But there is a pretty easy way to do that. Generally, what you would do is you would just write a simple generator function that probably looks something like this. So function random sample, and then from there you specify path to the various images, and then you specify the batch size, and then when you use it, when it gets evaluated, it's going to be something like you give it an association. So here, batch size 4. So yeah, you would just write a generator function that, when you evaluate it, loads a single batch from some external source. This can be from another folder on your computer to a URL to some database, and then you can do net train using the net, and then the second argument would be your generator function, and then it calls the function at each training batch iteration. So it would only keep a single batch in memory, and allows you to basically not have to use memory to hold all your data. So it's actually pretty simple to do, but for this example, I just didn't feel like it was necessary. So hopefully this demonstrates how easy it is to sort of get up and going with using the neural net framework in the Wolfram language, especially we looked at comparison between the ease of use of neural net framework in Wolfram language versus the Keras neural net framework in Python. In addition to the framework itself, the notebook kind of lends itself to the user friendliness and sort of the intuitive feel, the ability, the symbolic representation of neural nets, that you can click around with, coupled with, auto-completion of pre-trained models for selection, and a few other things, really kind of create a very nice workflow for people who are not, machine learning experts like myself. I don't have that background. Thanks for joining me.